Alrighty, so here we are on Lesson 5, Chance Experience with Outcomes that are not equally likely. Okay, so they gave us a table here in example 1. It says, when Jenna goes to the farmer's market, she usually buys bananas. The number of bananas she might buy and their probabilities are shown in the table below. Alright, so part A says, what's the probability that Jenna buys exactly 3 bananas? So that means we're just going to look where it says 3, and it's 0.2. So remember to change this decimal to a percent. You're going to multiply by 100. So it would be 20%. B says, what is the probability that Jenna doesn't buy any bananas? So that means she bought 0 bananas, and that's 0.1. Again, times 100. So that's about 10%. C says, what's the probability that Jenna buys more than 3 bananas? So we can't include the 3, so we're looking at 4 and 5. So this is going to be 0.2 plus 0.3, and this equals 0.5, which is 50%. D says, what's the probability that Jenna buys at least 3 bananas? So that means we're counting 3, 4, and 5. So 0.2 plus 0.2 plus 0.3, and when you add those up, you get 0.7, which is 70%. And then part E here says, what is the probability that Jenna doesn't buy exactly 3 bananas? So she doesn't buy exactly 3, so that means she could buy, 0, 1, 2, 4, or 5. So instead of adding all those up, what you can do is you can take that one whole, which is the 100%, minus the chance that she would buy 3 bananas, which would be 0.2. So you get 0.8, which is 80%. Okay? So it says, notice that the sum of the probabilities in the table is one whole. And it says this is always true. When we add up the probabilities of all the possible outcomes, the result is always 1. So taking 1 and subtracting the probability the event gives us the probability of something not occurring. So that basically talks about what we did up here in part E. Alright, go ahead and flip the page. So it says Jenna's husband Rick is concerned about his diet. On any given day he eats 0, 1, 2, 3, or 4 servings of fruit and vegetables. The probabilities are given in the table below. So on a given day, find the probability that Rick eats 2 servings of fruit and vegetables. So 2 servings in the table is 0.28, which is 28%. B says more than 2 servings of fruit and vegetables. So more than 2 means 3 or 4. So 0.39 is 0.12, which gives us 0.51, which would be 51%. C says at least 2 servings of fruit and vegetables. So at least 2 means we're including 2, 3, and 4. So we have 0.28 plus 0.39 plus 0.12. And when you add those up, you get 0.79, which is 79%. Right now here in 35, it says find the probability that Rick does not eat exactly 2 servings. So that does not is our cue that we're going to use 1 minus and then the actual probability of eating 2 servings, which is 0.28. So 1 minus 0.28 is 0.72, which is 72%. Okay. So now in the next table down here, they gave us fractions. So Luis works in an office and the phone rings occasionally. The possible number of phone calls he receives in an afternoon and their probabilities are given below. So find the probability that Luis receives 3 or 4 phone calls. So remember that when we see the word or, this means to add. Okay. So 3 or 4, so that means we're adding 1/3 plus 1/9. And remember, you need a common denominator to add fractions. So our 1/3 to become ninths would be 3/9 plus 1/9. And when we add those, we get 4/9. So now if you divide that in your calculator, pull up my calculator here to show you, 4 divided by 9, you get 0.44 repeating. So if you multiply that by 100 times 100, you get 44.4 repeating percent. So when you have a repeating decimal, you have to include that in your percent. You can't just round up to 44. Alright, find the probability that Luis receives fewer than 2 phone calls. So that means we're adding 0 and 1. So 1/6 plus 1/6, which is 2/6. And when you simplify that, that's 1/3. And we know when we divide that, we get 33.3 repeating percent. C says find the probability that Luis receives 2 or fewer phone calls. So now we're going to take that 1/3 from above plus the probability of getting 2 phone calls, which was 2 9s. So if we need to add those, we need a common denominator. So we would have 3 9s plus 2 9s, and this equals 5 9s. When you divide that, you get 55.5 repeating percent. And then our last one, D here, find the probability that Luis does not receive 4 phone calls. So we're going to do 1 minus the probability of receiving 4, which is 1/9. Remember, 1 whole would be 9 9s minus 1/9, so we would get 8 9s. When you divide that, you get 88.8 repeating percent. Alright, we're going to do one more on the next page at the top here. When Jenna goes to the farmer's market, she usually buys some broccoli, and the possible number of heads of broccoli that she buys and the probabilities are given in the table below. So find the probability that Jenna buys exactly 3 heads of broccoli. So 3, that's 1/4, which we know is 25%. Does not buy exactly 3 heads of broccoli, so that would be 1 minus 1/4, which is 3/4, and 3/4 is 75%. Buys more than 1 head of broccoli, so that means we're adding our 5/12 plus 1/4 plus 1/12. So we can add the 2 of those. Those are 6/12. Plus, now we have to change the 1/4 to a 12. So that would be 3/12. So we'd end up with 9/12, which if you simplify is actually 3/4. And we know that is 75%. So always try to simplify first before you have to pull out the calculator. And then buys at least 3 heads of broccoli. So we're going to add our 1/4 plus 1/12. And then we need a common denominator. So 3/12 plus 1/12 gives us 4/12. And when we simplify that, we get 1/3, which I'm pretty sure by now we know is 33.3 repeating percent. Okay. So in this last example, the diagram shows a spinner designed like the face of a clock. The sectors of the spinner are colored red, blue, green, and yellow. This one I want you to try on your own. Alright, so if you count up the number of spots, there is a total of 12 pieces. Okay. So I want you to try the rest of this page, and then it goes a little bit onto the next page on page 19. So you're going to try those on your own, and then we'll talk about them in class tomorrow.